Nomenclature continued, everybody. We fixed 2 typos in this next question. There was extraneous number 1 and a dash here I got rid of. 5-223 trifluoropropyl. I finished the parenthesis. That was my second typo. So we're going with this name now. And we got a new group at the end there too, neopentyl. Wow. All we know is there's 5 carbons in it. And then there's, yeah, pent is 5. And that's a unique pattern, the neo pattern. And it's not like iso or sec, where you have like 17 of each. You have isos all the way from propyl to icossyl, okay? And you have sex all the way from butyl to icossyl. You have only one neo, and it's right here. There's only one neo, and it's called neopentyl. There's no other neos. So we're going to draw tridecane first, 13 carbons. 2, 4, 6, 8, 10, 12, 13. Why that line interrupted, I don't know. Now it looks terrible. There we go. Not too bad. Let's go left to right this time. So 1, 2, 3, 4, 5, and 6. See that? I only put numbers where I need them. So we've got this 2,2,3 trifluoropropyl group. What do you draw first? Don't draw the trifluoro, please. What's the part attached to the chain? Propyl. Draw a propyl. How do you draw a propyl? How many carbons? 3. 3 carbons in green. 1, 2, wow. 2, 3. I know it's going into the next name. No big deal. Now, how do you put 3 fluoros on there? Tell me, where does the first fluoro go? This is new stuff, by the way. You see the parenthesis? Okay. Inside the parenthesis, any number in there refers to where the group's attached to propyl. This number outside the parenthesis has nothing to do with the propyl. It's where this group is attached to the chain called tridecane. Inside the parentheses, where are these fluorines attached to the propyl? You need to know the most important new rule for parenthesis groups that have numbers inside. Carbon 1 inside the parenthesis is the carbon attached to the chain. Don't invent your own rule. Carbon 1 of this propyl you just drew is this carbon and this carbon only. The one attached to the chain is carbon 1 in the propyl group. There is no fluorine on that carbon. How many fluorines are you going to put on the next carbon, which is number 2? 2 fluorines. What's the symbol for fluorine? F. You know what happens on the exam when you put FL? I'll tell you the 2 stories. 10 years ago, if you put FL on your exam, I write Florida, question mark. Now I write fluorovium, question mark. It is an element now. Check out your periodic. So it's not that funny. I'm sorry. But as a teacher who's a fan of the periodic table, to me, it's interesting. And there's a 3rd fluorine where? On the 3rd carbon of propyl, correct? Congratulations, you just drew a trifluoropropyl group in green off of carbon number 5. And then what's on 6? We got to learn our neopentyl. She said chicken foot earlier, she's close. Chicken foot, the tert butyl group. But if you draw like a chicken foot tert butyl, that's an aside here. There's your chain. And that does look like a chicken group, foot, right? Tert butyl. Now, a neopentyl's got a CH2 before the chicken foot. So I call it a broken chicken foot. It's a broken chicken foot. So you just do a CH2 and then connect a chicken foot at the end. There you go. See the chicken foot? There it is, the chicken foot at the end. and it's got the extra CH2 right before it. That's the only neopentyl that exists. Okay, and I think we got everything we need there.
Can we name that?
There's another way to name the neopentyl with the system we just learned, numbers and parentheses. Do you want to do that? I think it's a great exercise. Instead of calling it a neopentyl, you could have had this 6 dash. What's the longest chain in the group? Starting with carbon number 1 in the group right here. 1, 2. You can't go back to the red, okay? You're only looking at the group. 1, 2, 3. It's a propyl group. Where's carbon number 1 of the propyl group? The one attached to the chain. There's 2 methyls off of carbon number 2. And I don't think I have room. 2, 2. Please. Please. Oh. I can't do it. That's why we have erasers, right? 2,2-dimethyl propyl. Once again, the groups attached to the propyl are first, then the propyl. And that's an alternative name for a neopentyl. I'll highlight it. 6-neopentyl could be replaced by 6,2,2-dimethyl propyl. Yeah. And you can go back here and call this group a 1-methyl propyl group.
So either
Or 1-methyl propyl. Both systems are exactly as good as each other. They're both acceptable. So in this case, we're instead of a sec-butyl, you'll notice the systematic way is longer, but it's also very systematic. It's got a plus and a minus. Next one, so we got this up here. Cyclobutane is what I'm drawing first. How do you draw cyclobutane? Square. Hey, chloro. How do you draw chloro? Cl. Big C, little l. Notice I don't worry about cis or trans till the end. And what's this group on 3 called? And there's carbon 1, there's 2, and there's 3. Trichloromethyl. How do you draw that? Talk to me. What are you going to put on the page? I like it. A C with 3 Cls. That's exactly what it is. Remember, trichloromethyl. The chloros are attached to the methyl. The methyl is attached to the cyclobutane. That's a nice way to do it. Yeah. She had it drawn out for me like this, which was perfectly acceptable. And then she drew a stick to each of the chloros. That's the safest way to do it. And now trans. Talk to me.
We could do one.
So one's a wedge to the Cl, and the other's a dash to the Cl.
Yeah.
And below, if you did a wedge to the Cl and it's trans, the other group better be a dash. Make sure the dash goes all the way, please. Similarly, if the Cl was on a dash, then the other group's on a wedge. Make sure it goes all the way to where the intersection is. That's an or. Both of those would get full credit. And finally, we're going to get to a chicken foot. And I like it because the tert butyl's there. That covers 4 carbons. You know how you make that into a tert heptyl? Because that's what we're going to have to do. You pick one of the toes and add the right number of carbons to get up to 7. So 3 more. 1, 2, 3. We'll draw it when we draw our molecule. And the molecule starts with 521, 2 dots. And I'll go with a 5 in the middle just for variety. 1, 2, 3, 4, 5. Told you didn't have to look pretty. Mission accomplished. 1, 2. And then, oh boy, can I even get them to connect if I do this? I may have created a monster. I don't know how to get, like, okay, there. But then we got a problem. There, I fixed it. I need my eraser. So, point to self. It just gets difficult to draw if you put the small bridge on the outside. It just makes you just made your job a little harder. But you know, it's not wrong. You saw the trouble I had. I got to get one carbon without intersecting my other bonds there. Would have been better to have that in the middle, wouldn't it? So you decide number 1, you want to go bottom. If you decide that, you have no more decisions to make. Where's 2? Up to the left. It's got to be in the biggest bridge. And how do I know this is number 7 without putting all my numbers down? I could put the numbers down. I got to have 5 between the 1 and the 7, because that's what the name says. And I got to get up to, I need number 3, because there's something on 3, and I need number 10. So where's 8? Because this is 7, where's 8?
To the right.
Yes. The next biggest bridge is this double. And yeah, we're going to put a group on 10. Tert hepto, we'll put on 3. Here's the end of 3. You draw a chicken foot. For every tert, you start by drawing the chicken foot. There's the chicken foot, you see it? That got you up to 4. I got to get up to 7. You pick one of the feet, and you add 3 more to it.
Does it matter which one?
Doesn't matter which one. So I got more room to the right there. 3 more. 1, 2, 3. Just verify you got 7 carbons there. You get the chicken foot for 4, 5, 6, 7. And then on 10, you're going to draw an iso undecule. What? I got a system for drawing isos that's real easy. You draw, in this case, you don't draw 11 carbons in a row. It's 10. Do you agree undecule, when you're finished, better have 11 carbons in it, right? Undecule means 11. Don't draw 11 in a row, because that's just an undecule group. Draw 10 in a row with a V on the end. Because the V on the end means what pattern? Iso, that's this pattern. So 10 in a row. Here goes, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And where do you put the V? Yeah. You got to put it like there. See it? Second from the end carbon. Verify you got 11 carbons in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Iso undecule. And then we're going to do cis. How do you properly show cis? There's 2 ways. We're going to only do one this time. Wedge, wedge. I like wedge, wedge. Do it in blue. Clearly a wedge there, and clearly a wedge there. Make sure it goes all the way to that intersection up there. That's good. Man, that's a lot of nomenclature. Guess what's next? More nomenclature. What I'm going to do is we're going to pull a fast one on you. We're going to, actually, there's a teeny bit of new nomenclature in chapter 3. I know, we're not done 2. Don't freak out on me. Because we're rolling with nomenclature, let's stick with it. And we'll do a quick intro. You're going to have to spend a lot more time on your own to learn something called stereo centers. They take practice. I'm just gonna give you some things right now. And you're gonna practice. Because the stereo center's on every exam until the end of chemistry with me. You don't want to keep throwing away the same point. So here we go.